we've misunderstood the heart and its true function, as well as the pathology of heart disease and why the body's doing those things. I think that it's the same kind of thinking. I think that it's big push in ancestral movement for like barefoot, that kind of stuff, and there's a lot of companies out there. Me as a chiropractor, I work with them that would say that you need orthotics. That's what you need. And I would say that we weren't born with orthotics.
Mm-hmm.
So if something's wrong with the foot, it's not because of a lack of orthotics. So we've misunderstood the function. We tend to think that we as a society tend to think that we know better than nature, so to speak, or nature got it wrong. We're smart enough to figure it out, and that's the same kind of thing we've taken, or the same kind of approach we've taken with heart disease, is that nature got it wrong, or nature is doing something wrong, like forming this atherosclerosis, and it's really just responding to the environment that we put it in. And in many cases, it's doing things to protect itself. And we're seeing it as pathology, when in reality, the body's working exactly as it's supposed to. But long-term, it's an issue. And so we have to change the environment rather than thinking we can go in and just correct it and have like an egotistical approach to it. We have to step back and, I guess, be humble in nature, realizing medicine should really be about learning when it's important to intervene, but more importantly, when it's important to step back.
Human.
Les humains à leur meilleur.
C'est tu apogeo.
Hello everyone, welcome back. I'm Brian Sanders. This is Peak Human, but you already know that because you started back at episode 1. You've heard all the great guests. You know about the Sapien diet and lifestyle. You know about the Food Lies film. You know about Nose to Tail. Today I have a great guest, Dr. Stephen Hussey, and we talk about the heart, a whole new paradigm of how it works. Just a few updates before I jump in. We actually are filming a bit more for the Food Lies documentary in a few weeks at a great ranch in Oklahoma. I can't stress enough the lengths we're going to make this the absolute best film possible. We need a mic dropper, jaw dropper, kale shake dropper film. Anything less won't work. It won't reach the mainstream. It won't reach Joe Cheeto out in Ohio. It won't reach the vegan in the coffee shop with the soy latte in Santa Monica. It definitely won't reach the hilarious jokesters at the Harvard Chan School of Public Health with their comical Eat Lancet funded diet for planetary health with more added sugar and 3 times the seed oils than meat. Well, it probably will never reach those bought and paid for fake scientists anyway. But we're going to make it that good where someone there might watch it and realize they're living a lie and quit their job, quit their Kellogg's and Coca-Cola funded position on the spot. That's how good it's going to be. Foodlies.org if you don't know what I'm talking about, or catch my Instagram at food.lies where I posted the hilarious diet that the jokesters at Harvard tried to post. Anyway, Dr. Stephen Hussey has a really new interesting paradigm on how the heart works and how atherosclerosis and other problems develop based on a bunch of research he's looked at. I don't think anyone's put it together like this before in one model like he's done. Very intriguing stuff. He attained both his doctorate of chiropractic and master's in human nutrition and functional medicine from the University of Western States in Portland, Oregon. He is a health coach, speaker, and author of 2 books on health, The Health Evolution, Why Understanding Evolution is the Key to Vibrant Health, and The Heart, Our Most Medically Misunderstood Organ. Dr. Hussey guides clients from around the world back to health by using the latest research and health attaining strategies. So another thing before we jump in, nosetotail.org. Everyone should have heard about this by now. It's my company where I connect with great ranchers doing things the right way. We have primal ground beef, most popular product, organs mixed in, liver, heart, kidney, and spleen. We have all kinds of other meats, pork, chicken, bison, lamb. We have seasonings that I actually use at every meal, no joke. Just put the fresh catch on some smoked oysters, mix in the Dillon Ranch with some goat milk yogurt, grill some steaks with the Primal Special. Getting the soaps back in stock, we make the soap out of regeneratively grown beef tallow. We use that good kidney fat to suet. Also got some cutting boards, some hats, some great stuff to show you know what's up. You know that meat's a health food. You're not messing around with the fake vegan foods. That's at nosetail.org. Also sapien.org. We have 3 lifetime memberships left to the Sapien Tribe. You get all the bonus content, the extended show notes, private Zoom calls, private website, access to Dr. Gary and myself. We got a lot going on there every day, actually, now. So check that out, sapien.org. And the program, of course, still got a special price for that. Online 12-week program led by Dr. Gary. We got your back. Check it out at sapien.org. And now on to the show with Dr. Stephen Hussey. All right, we're live with Dr. Stephen Hussey. How are you doing today?
Pretty good. How are you?
I'm great. I'm glad that you came to the event in Maryland with Dr. Bill Schindler, the Journey Through the Ages, the amazing food event. How'd you get, are you close?
Yeah, to him, yeah, we're not that close. We're probably like 4.5, 5 hours away, but I went up and did an event for him at one point before COVID hit and everything. And so I saw he was doing an event and just wanted to support him. And it was a great event you guys did. So
it really was amazing food. We went through the courses each course was a different eon really, or like epoch in human history. And
yeah,
that was great. So I got your book. You brought me your book, which is awesome. Understanding the Heart, Uncommon Insights into Our Most Commonly Diseased Organ. So we'll be talking about that today. But you also wrote another book. So what was your first book called?
it was called Health Evolution, Why Understanding Evolution is the Key to Vibrant Health. And it's basically a big picture understanding of where we've come as humans and why that helps explain why we have chronic disease in general and what that means for, I guess, the future of chronic disease, but also the future of humans and making sure that we're involved in the future of the planet.
I love that. Yeah, it's all about these ancestral principles, mismatch diseases. I mean, I didn't read that book, but you kind of alluded to it in the beginning of this book about mismatch disease. And I mean, there's other books on that stuff too. So many listeners are probably aware of that, but maybe you could tell us more about it in a few sentences, and then we could jump into who you are.
Yeah, for sure. Yeah, like in that book, I really focused on understanding evolution because it was that gave me, I guess, the insights. I looked for, I've been passionate about health for a long time, and I was looking for all these answers, in my own research. And it was really when I understood evolution that I started to put together how humans got to the point where we are today, where we're, so chronically ill, especially in westernized countries. And so I really tried to lay that out for people and have them understand evolution in the way that I did, that kind of enlightened me as to why that is, and then relate that to how our changes and modern ways of living can contribute to the diseases that we're seeing. But without that baseline understanding of evolution and how it works, which I think people have skewed views of, then it's really hard to understand that. So I tried to lay that out for them.
It's great. That concept is so on point. I think it's really all that matters is it's kind of like making populations more dense screws up everything. I was just thinking about it while reading this newer book. It's about the density of population. When you move to cities, density of population dilutes nutrients in a way. Like you can think of it like the farther away you get from the source of your food, the more you kind of dilute the nutrients. More food processing dilutes it, more just non-fresh food. And then there's also all the other factors of living in a city, whether it be pollution or all that other stuff. So is that kind of what your first book was talking about?
Yeah, I mean, that's one of the huge issues, I think, is living in a city is a drastically different environment than what humans have been in. And even the context of modern day, living in a city versus a rural area is so much different of an environment. And so I oftentimes give like an example of like the China study, how they do that. They did that type of research and they didn't account for the fact if people were living in rural or city areas, and they saw that people that ate more meat lived in cities, and they're like, oh, they have more heart disease. But they didn't account at all for the fact that they were living in cities, and that contributed to their heart disease in many other ways, like chronic stress, toxin exposure, all kinds of stuff. And the people in rural areas, quote unquote, ate less meat and had less heart disease, but they were also, it wasn't the meat or less meat they were eating, it was all the other beneficial things that came from living in a rural environment. So you can see that contrast. And sometimes how it's not taken into account for studies like that.
Well, yeah, but even so, I always bring this up about the Tuoli province. In that study, the Tuoli province ate the most meat and they were the most healthy. So
Mhm.
actually don't even know if it sounds like it was probably a more rural environment and that they just happened to have all that meat at their disposal.
Yeah, and I think they left some of that data out too when they
Exactly.
published it. Yeah.
Yeah, and then well, this is from Denise Minger, who I interviewed years ago, and
Mhm.
yeah, she like wrote an amazing breakdown of the China study. People can look that up. Uh, yeah, so maybe you should go
Definitely.
into your personal history. I know you are type 1 diabetic.
Yeah, yeah. So that kind of, I guess, fueled my passion for health. Was that well, I guess even before I was diagnosed with type 1, I had a lot of inflammatory conditions. I had like IBS and asthma and terrible allergies. I used to break out in chronic hives all over my body, just huge hives, and they never really figured out why. But I was just in this inflammatory state, and eventually wound up with autoimmune type 1 diabetes at age 9. And so, yeah, that kind of thrust me into the Western medical system. It was the only thing, me and my parents knew what to do about that. And so they taught me how to manage these conditions, but manage is the key word there because they never really taught me why they were happening, and what to do about them as far as trying to get rid of them. And so, as I grew up and especially in college, I started to realize that how I live my life directly impacted my ability to manage these things, and some of them even went away when I started changing my lifestyle. So all those inflammatory conditions that I once had are now gone. Like we have cats, and I'm not allergic to them now. And so, but that type 1 diabetes was kind of collateral damage that happened, and so I will have that as far as I know until maybe they come up with some kind of cure or whatever. But I started to notice as I was going to endocrinologists throughout, high school and college and everything, that there was all these signs that I was at increased risk for heart disease because of higher blood sugars and things like that. And so I'd asked the doctors why that was, and they said, yeah, it's because you get damage to the small arteries, so you'll get eye damage, you'll get heart disease, you'll get um, loose feeling in your feet and that kind of stuff. And so since then, or since I kind of grasped that concept, I've just been really focused on how to try and prevent atherosclerosis and heart disease and things. And so I've accumulated all this information, and at even throughout like my medical education as a chiropractor, and I got my master's in nutrition, all that stuff. I just kind of had an ear for that stuff, even though I feel like I didn't learn too much about what causes heart disease in those educations. Um, and so eventually I had all this information, and I decided to put it down in a book and start sharing it, and people liked it, so I kept doing it.
I like that. No, it's a similar story to myself. Well, you have more medical training than me. Like you just said, you're a doctor of chiropractic and you went to master's in nutrition. But I am kind of like that. I'm coming out of left field as a mechanical engineer and trying to put together a lot of information based on my own personal story of getting into health. And so I don't think that discounts me. I mean, I guess I'm not, going to ever be a cardiologist or someone who is an expert in that certain field, but that doesn't discount me necessarily from synthesizing information and getting it out to the public, which is what you do. So I love that. Yeah, I mean, so I guess the disclaimer is yes, you're not a cardiologist, but you wrote a book about the heart, and it's very interesting. And you pull together lots of great scientists and researchers and their ideas to come up with this book and these new ideas.
Yeah, and I think that the moral of the story there is that I did this because I wasn't getting answers from traditional, doctors, whether it be endocrinologists or cardiologists. I asked them how to prevent these things, and they basically told me to, eat a good diet, exercise, and take medications when they prescribed them.
Hmm.
And
And what was
that
their good diet?
yeah, well, it was definitely, it's pretty amazing actually. It's pretty much a processed food diet,
Yeah.
where they tell you can eat, and so in the book I talk all about how a processed food diet is probably the worst thing you could do, for preventing heart disease or any disease really. But that's what I was being told to eat, and I was given a booklet I remember when I was a kid, probably when I was in high school, maybe 14, 15, 16, something like that. I was given a booklet that listed every single thing that was available on every fast food menu in the United States. I feel like, whether it went from Arby's all the way to, whatever fast food starts with a Z, and it just listed the carbohydrates in it, because that's all they cared about as far as the type 1, because I was supposed to give myself insulin for carbohydrates. But it was basically telling me, eat whatever you want, just make sure you give yourself insulin for it.
Just
It
match
didn't
the
matter.
insulin with, how much?
It didn't matter if that was 20 units of insulin at some point, which is a huge dose. I consider a huge dose. That was fine as long as you covered it. I mean, the main goal was controlling the blood sugars, which was good, but they did not understand how the vegetable oils in those meals were making it extremely hard for me. They're breaking my metabolism, making it extremely hard for me to control blood sugars at all. Even taking the fact that I'm trying to act like a pancreas out of it, just breaking the metabolism with that type of diet was terrible. And so I had to find my way out of that mess and figure out everything that I could do to help control blood sugars, which there was no help. So yeah, I'm not a cardiologist. I'm just have an interest in the heart. I do have, a medical background, and I have training in, reading studies and critiquing them and things like that. But I didn't write this book to fly in the face of cardiology or cardiac research. I wrote it because it interests me and I feel like it could help people. And it's just me trying to understand the disease I'm supposedly predisposed to.
I think that's super important, because reading your book and just knowing just science and medical stuff in general is, we don't know a lot about heart disease, right? The standard idea of it seems to be super wrong, and or just a lot of holes in it or something, right? It's not all there. And so you're just trying to put together some of these pieces, and it's starting to make more sense once I started reading some of your things. So also, well, before we go on, we can go through the book, because I think it's really cool to just kind of go through it and just go through your flow that you went through in the book. But how long did you, before you figured out kind of how to manage your diet and lifestyle a lot better, sounds like you spent some of these early years of your life just eating whatever and not having great health?
Yeah. In high school, I remember my A1C topping out at 11.2.
Whoa,
So in high school, I was not taking care of myself.
that's not
And
good.
I was a rebellious teenager, and it was a bit of a struggle with my parents and I, because they would always be asking me what my blood sugar was. And I didn't have the foresight at that time to see the damage that could be done, in the future. But yeah, so from the time I was diagnosed, I remember, cereal was my favorite food. We used to, have toaster strudels for breakfast. I don't know if you know what those are, but
Yeah.
yeah, and that kind of stuff. And we had, generally, I guess, healthier meals at dinner, but it was standard American diet, and that was my entire childhood. And I remember, I was diagnosed at 9 years old, and I didn't hear the words low carb or anything for a type 1 diabetic until maybe 11 or 12 years later. And so it was a long time on that type of diet. And I probably started changing things most significantly maybe my senior year in college. And at that point, it was just moving more toward whole foods, because I majored in health and wellness in college and was starting to get that message a little better, which was good. But it was probably, so I've been diabetic for 25 years, and it was probably at least half of that it was the standard American diet.
Mm.
And then probably a quarter of it was experimentation time. It was just like I was trying to find the right diet, like whole foods first, and then I had like a vegan phase, and then I went paleo, and then finally low carb. But it's really only been like the last 5 or 6 years, I'd say, where I feel like I have my diet figured out and I've got what works best for me. Yeah.
Well, yeah, we didn't really know that much. Even the carnivore, I know you tried carnivore for a while, and it's like that didn't even come about until 3 years ago.
Right. Yeah. And I definitely saw some benefits from that. I've since moved on from that, but it's the first time in my life that my gut didn't have any symptoms, which was pretty huge for me. And since I've gone away from it, I still don't have gut symptoms. I don't know if they'll come back eventually, but from eating certain plants or whatever. But yeah, it's like it allowed my gut to heal. And it's the best it's ever been now.
That's great. I guess you're probably on something more sapient. I keep trying to coin my version of things where it's animal based, but we're having whole foods as well. Sounds like
Mhm.
that's what you do now.
Yeah, definitely. And the main thing is diligently avoiding processed carbohydrates and vegetable oils at all costs, and then yeah, and eating for like I guess nutrient purity. I guess so like you want energy source, whether it's a fat or a carbohydrate, and you want foods that are very nutrient dense, and just focusing on that. And then outside of that, I don't think it matters too much. Whole food diet is going to get you metabolically healthy. But then certain people have to pay attention to plant toxins and maybe things like dairy or eggs, things like that. So you just kind of have to be conscious of those and how they affect you. But in general, yeah, whole foods, nutrient dense.
Yeah, what animal sources are where the nutrients are. Uh,
Yeah.
cool. So let's start going through your book because I thought it was cool. You started at the very, very beginning. You didn't just start with evolution. You started with the primordial soup. So tell us a little bit about that and why that's even important and why you started there.
Yeah, I've really been fascinated with life and the earth sciences and natural sciences for a long time, and so this was just something that I felt was important to include because it shows that the things that formed our physiology at the very beginning are playing a role today in heart disease, and I think it's just important because we think of it as a modern day disease, and it is, but the parts of our physiology that it's affecting were formed a very long time ago, which makes even more sense when we think about the fact or how quickly things have changed recently. There's no way that those very you know old evolved mechanisms could adapt to that. And so yeah, I start with the story of how the earth had the atmosphere had a certain I guess ratio of certain gases, and that started to switch. It started to become more oxygen in the environment, and the cells started to take, or some cells or some beings started to take advantage of that. And eventually, interestingly enough, there was a certain creatures that kind of engulfed other creatures, and the little ones that they engulfed were really good at using oxygen to fuel whatever they were doing. And so they kind of formed this symbiotic relationship that has stood the test of time. And we see evidence of it today in our modern day cells. We have these little things called mitochondria that look very much like their own bacteria. And it's almost like, those bacteria, they have two cell walls. So it's like they were their own thing, and then they were engulfed into the cells that we have. That's some evidence for it. But there's even some evidence that these things can exist on their own. They've even been found on their own in our bodies, in the bloodstream. So it makes sense that they were once on their own, and they can kind of still do that. So anyways, this relationship happened because now that the larger cell that engulfed this newly formed, what we call mitochondria, had this structure that could use oxygen to make energy for it, it could focus on other things. And those other things were, becoming more and more complex life forms. And so it could focus on cell division and then cell specification, becoming different types of cells. And so, from that point, we start to get higher evolved organisms. We get plants, and then we get, fish, and then we get eventually reptiles, and then eventually mammals, and it just goes on and on all the way up to humans. But that relationship in the cell between the structures of the cell and that bacteria that we now call mitochondria, again, has stood the test of time. And it is the health of that mitochondria is extremely important, not just for heart disease, but for all disease. And our ability to use oxygen through the use of that bacteria is incredibly important for things like cancer, but also heart disease. So I wanted to illustrate that and talk about that story to give people a really good baseline for that.
It's important. And I had Dr. Thomas Seyfried on and talk about the metabolic, the metabolic theory of cancer,
Mhm.
and Otto Warburg, and he covered that stuff in the book. as well. Maybe you could kind of give an overview of that to catch people up.
Yeah. So it seems that cancer, when we observe it, we look at it, and it's these cells that are anaerobic, meaning they don't use oxygen. They're rapidly dividing. They're acidic, and so that kind of paints this picture that those structures in the body, those mitochondria, are not able to do their job, because if the cell gets to a state where it's that damaged or that compromised that it can't use oxygen, it starts to revert to this older evolved mechanism that it still uses sometimes, but it has to use this more now. And that's called lactic acid fermentation, or aerobic fermentation. So there's oxygen present, but the cell can't use it. So it has to use fermentation, because those structures, those mitochondria, are damaged. So the cell can't use the oxygen.
Mm-hmm.
And so this results in anaerobic cells, so cells that aren't using oxygen. They're very acidic because they're making and using lots of lactic acid for their energy production purposes. And then they eventually become very rapidly dividing, which is what we know as cancer, because a cell can't survive in that state. So the only way it can really survive is to rapidly divide and hope that a solution is found at some point down the line. It's kind of this short-term fix mechanism that has a long-term bad consequence. So yeah, that's kind of this metabolic theory of cancer. And so it all depends on the health of our mitochondria. And so the reason that it's a metabolic theory is because there are certain substrates that we can burn that are non-fermentable. So if we're trying to stay away from fermentation, away from that state that could potentially perpetuate cancer, we want to make available fuel sources that cannot be fermented. So that is a ketone. And so this metabolic theory of cancer is focused on, this low carb state where we're providing the cell with ketones, so that it stays away from that aerobic fermentation, because it can't do that with ketones.
Yeah. And I know people with cancer that are doing great for 10 years now, just using a keto diet and,
Mm-hmm.
checking with their doctor and all that and doing both sides. But there's a lot of great research on that.
Definitely.
Had Dr. Dom D'Agostino on as well, talking about this stuff. And that's a whole rabbit hole, but we should continue on to the heart. And I guess you mentioned reptiles, in another place you stopped in the book to talk about, stress. So why don't you jump into that?
Yeah. So I like Stephen Covey's expression, like, seek first to understand, then be understood. So like, I want people to understand why these imbalances are important. That's why I went into the history of the mitochondria and everything. But then there's also this history of our autonomic nervous system. And so our autonomic nervous system is just the system that our body uses to perceive if we're in a safe or threatening environment. And then based on which one we're in, we have the appropriate response. We either need to fight off that threat, or we're in a rest and digest state where we can, digest and sleep and procreate and that kind of stuff. But it's a bit different in reptiles than it is in mammals. And so in reptiles, they have, the nerve that communicates the signals for the autonomic nervous system is basically one pathway. It's called the dorsal motor nucleus. And that signal is, when it gets overwhelmed, like if the animal gets in such a stress state that it feels it needs to, the reptiles can actually shut down, and we know this as playing dead. And for some reason, that must have been evolutionarily advantageous, because it stuck around. It's still present in them today. And so they can literally shut down organs and slow the metabolism significantly, and not die, and to have this kind of response. However, for mammals to evolve, mammals are different than reptiles in that they're very metabolically active. We're warm-blooded rather than cold-blooded, because we're producing this heat, because we're metabolizing things all the time. And you think about mammals, they tend to be like running around fast all the time, whereas reptiles we think of are a bit slower. They move slower. And so in order for that to happen, there needed to be a stress response that wouldn't get overwhelmed, because if we had a stress response that triggered our organs to shut down, our organs are so metabolically active that they couldn't do that. They would die. They would get necrosis and die. And so we needed a different stress mechanism, so that when we had a stress response, it wouldn't result in that organ shutdown or that body shutdown. And so what happened was that there was a split in the vagus nerve, which is the nerve that carries the autonomic signal. And it split into the dorsal motor nucleus was still there, but then it split into the nucleus ambiguous as well. And this allowed us like mammals in general, to have a stress response through one of those pathways and not shut down, which was incredibly important, so that we didn't have that damage. However, I don't think that evolution was accounting for the very quick change in way of life for humans. So I do think there's a situation where it can cause issues still, or a prolonged stress response can still cause issues. But the critical thing there is that mammals in general are highly metabolically active, and the heart is actually one of the tissues with the highest amount of mitochondria, meaning it is one of the most metabolically active tissues in our body. That and the brain's pretty high up there too. And so when we do get this imbalanced state where it can slow or tries to slow metabolism, the heart is one that suffers because of that. And I think there's no coincidence that because of that, our heart is associated with our emotional state so heavily. Because we know that our emotional state positively or negatively affects the heart in ways that we can't necessarily understand or comprehend or don't fully understand yet. But it's all back to that evolved mechanism that allowed us to become mammals and allowed us to have a stress response without hopefully shutting down any organs.
Well, now, yeah. So you're kind of leading to like the problem we're in now, right? What, like we talked about, we're in cities and we're just with daily life, we're in this chronic stress state. And the idea is that this is a very new thing for humans to always be under stress. And this is kind of what you're saying with here. And how does it relate to the vagus nerve too?
Yeah. So, especially to the heart, I mean, all organs, but especially the heart, it's supposed to have balanced signal from the vagus nerve. There's sympathetic and there's parasympathetic. Sympathetic is more reserved for our stress response when we need to fight or get away from something. And parasympathetic is, rest and digest when we're in a calm, relaxed state. And people think of those things as like we're in one or the other. But in reality, they're both signaling at the same time, and we're supposed to get a balanced signal from them. So if we get a surge in sympathetic because we went through something stressful or something stressful happened to us, we're also supposed to get a lesser but also surge of parasympathetic to keep things balanced. And that's all communicated through the vagus nerve. And so what's happening is that that older evolved mechanism of the organ shutdown kind of route is getting triggered too much, right? So we're constantly in this state of low grade stress, and over time, that parasympathetic, that non-stress signal, gets decreased, and we call this decreased vagal tone in people. And so when you have that, then you're more prone to have negative effects from the stresses in your life because you don't have that parasympathetic balancing things out. And so there are many different people out there that talk about increasing vagal tone and increasing balance in the autonomic nervous system. So we have this balanced signal. So people do things like everything from like gargling or grounding or nature exposure or positive social relationships. There's all kinds of hacks and ways of life that people can live that can increase their vagal tone. But yeah, it's all about the health of that vagus nerve and not allowing it to go back to that older evolved mechanism of this one central nerve that leads to this overwhelming response and organ shutdown.
Yeah, so it sounds like there's more to it too. People like just going out of nature or like being in the ocean or going in the sun. All these things that you're talking about are just going back to sort of this ancestral pattern that we're used to. And that's why I think all the people have success. People in the ancestral health community, they do a lot of these things. They're getting better sleep and they're being mindful of their stress and they're doing all these things. So you're kind of just saying this is the pathway. This is actually what's going on in their body that is producing these good effects.
Yeah, this is the mechanism by which it's the imbalance is creating poor health, and if we recreate the balance in the vagus nerve, yes, we're going to see improvements in health. I mean, think about it. If if your body is constantly thinking that it's in a stress state, or it's threatened by something, say like, we're living in the bush, and a cheetah comes out and chases us or something. At that point, your body is not thinking about detoxification. It's not thinking about digestion. It's not thinking about procreation. It's not thinking about sleeping, anything like that. And so
Repairing cells. Yeah.
repairing cells, all this kind of stuff. And
Mm.
so if we're in that state chronically and we're not able to get into that more parasympathetic or balanced state, then we're going to see things like insomnia and sexual dysfunction. And like, if cells aren't repairing over time, we're going to get chronic disease. We're going to see all kinds of stuff, digestive issues, because there's an imbalance in that autonomic nervous system.
Yeah, and for me, it's pretty universal. When you go camping for a weekend and you feel amazing and everything is better, you're like, what is it? Is it the fresh air? What? No, it's all those things. You're just being a human again. And for me, the opposite of that, I have a problem with driving. Like I'm just so stressed out. Like it's not like I really know it until my shoulders are tight and I just feel terrible because this is not a natural thing. You're hurtling down a freeway at 80 miles per hour. My body's like, what is happening? This is crazy. So this kind of this chronic stress that you don't even know about. I mean, you could go your whole workday. I remember, when I was working normal jobs in the engineering world, and my shoulders were just so tight, and just everything about my body was tensed. But I mean, there wasn't overtly, it's not like I was being chased by a lion or chased by a murderer. It's just this chronic stuff you don't notice.
Yeah. And that's a good point too, because, we have these, highly evolved brains that can override, how our body is feeling about something, because we can be walking down the street of a city and hear all the horns and the sirens and things like that. And we know in our brain that those things aren't necessarily going to kill us right now. They're not a threat unless we're in front of the car, in front of the cab, but our physiology, when we hear that initially, it's alarming, right? And we've just trained ourselves to turn that off through our mind, but it doesn't mean it's not having an effect on our physiology. And so that's why when you go back to nature or whatever, and you hear these sounds, the ironic thing is that sometimes people who are born and raised in the city, going to nature is actually stressful for them. So it's almost like their mind
like, where's my phone? I don't have reception.
Well, it's like the opposite too, because all the sounds are getting maybe calming the physiology, but in their mind, they've been programmed to think that there's things out here that are going to hurt them. And it's like the opposite. It's really interesting, but that that stress response is it's not, just like many things when a human is born, it's not fully developed, and so it's really important when a child is born, and it's why we do these things naturally as humans, is we look at the baby's eyes, we gaze into it, we make soft, gentle noises, we reassure it, we put it in a safe environment, because that baby's nervous system is learning what is safe. It's learning what its baseline safe is, and this is why things like childhood trauma are so problematic in society, because they teach the baby's nervous system the baseline is off, and so they're more prone to get into that stress state because they've been using it since they were a child, rather than having that good baseline, that care. Does that make sense?
Yeah, well, I know it's true. I talked to Dr. Tro a long time ago that deals with a lot of obese patients, and he said the vast majority have childhood trauma. And then, it really hangs on to you, and they end up with, I guess in his case, eating disorders or, just stuff around food. And yeah, I think it's huge. Also, what I liked about your book is you told these kind of anecdotes, a lot of them back when you were growing up. And one of them was cool. We're the only species that can just develop stress in our heads, basically. And I've always been interested in this concept of it's how you react to the situation matters. It's like something can happen, but really is it how you react to it is what matters. And so maybe you could go into that.
Yeah, we are unique in that we can think our way into a stress response. And a guy who's done a lot of work on this is Robert Sapolsky of Stanford. And he's basically shown that, us thinking that we're in a state of stress, or thinking we're in a threatful situation when we're not, because it's like we perceive things that are non-life threatening as life threatening, issues. Are we going to pass that test? Are we going to keep our job? Our kids going to be okay? That kind of stuff. And if your kid's okay, is a legitimate stress, but most of the time they are. But our world around us is programmed to think that they're not going to be okay. And so with these higher evolved brains, we can think our way into that stress response. And then it's not just something that, it's also the issue that, we can see something stressful happen to somebody else, maybe 1,000 miles away from us, and then fear it's going to happen to us, or we could have something stressful actually happen to us. And instead of this is what Sapolsky has illustrated, that like in nature, like if a zebra gets chased by a lion, it has a stress response while it's being chased. And if it gets away, the stress response is gone within like 2-3 minutes. But if we have that stress response, we could literally think about it, for a month or 2 months or the rest of our lives, be fearing that again. And, in a way, in I guess, a more traditional or more natural environment that we came from, that could have been helpful. That's why it's preserved in us. But in a situation where we're constantly, like in modern day, where we're being constantly told all these things are going to happen to us if we're not doing this or not doing that, then we end up being in this state of fear. And we feel like we're out of control, which is the worst form of stress, research shows. Like you're out of control or in unpredictable situations, rather than having control, rather than, thinking your way through things and forming control. So it's a crazy, I guess, paradigm shift that we've had, and the way we think about stress, because it's not just being stressed, because studies show that you could have a lot of stress on you, but if you're in control of that stress, or like if you have a high demand job, but it doesn't stress you out, that's fine. But if you feel like you're out of control or in unpredictable situations, that's when it's an issue. And that's when human brains just go off the chain, and they think too much and get us into these situations.
Well, that's why I refuse to watch any news or read any news, or just it's all about fear, and it's all just stressing people out, and you can't worry about it. All this stuff is so divisive, and it just gets people to hate each other. And I'm just so against all that stuff, all this political stuff, all this COVID stuff even was just a huge stress on people, where they were made to believe that they had no control. And all the mainstream stuff was, you have no control over this, and all you can do is stay home and be afraid, instead of the message of let's get healthy. You do have an immune system. You can affect your health. You can make changes. Yeah, I don't know. I think you were on Saladino's show. I think I may have listened a while back. Did you guys? Was it like a COVID talk?
Yeah,
What did you guys talk about?
Yeah, we talked about COVID and like what predisposes people to worse outcomes, which was metabolic health and stuff, and then how potentially some of the therapies to treat things that come about in metabolic health, like high blood pressure and high cholesterol and whatever, even though that's not an issue, but how some of those treatments could actually predispose people to worse outcomes as well. Some of the things like Western medicine is doing to do that. Yeah, we talked a little about that.
Yeah, well, it's just sad that I've seen these people that they get so scared. They're just in this chronic state of being afraid. And I always talk about my like little anecdote of just all the people I knew. We were in LA, we were doing our thing, we were getting together, we were living life healthy, we were interacting with each other, and no one got it. And then all the people that were scared and they, stayed home and they probably lowered their immune system and ate junk food, they all seemed to get it. I don't know. It's just this very unscientific thing that I noticed.
Yeah. And I think that, and that's the thing, is that I always go back to like what we evolved in and what our brains are meant to process. And, scientists say that we're evolved to have about like 100 to 150 close relationships,
Mm-hmm.
and the size of that tribe and what's going on locally there is about what we're designed to handle. And so then we start broadcasting all the crazy things going on all over the world, and our brains are not designed to handle all that, and I do think that, it's hard, because I want to say if something happens locally somewhere, then the world shouldn't know about it. It should be handled locally. But unfortunately, we're getting to a spot now where something could happen locally and it could affect people all over the world, because we're just that connected. We don't have these little local tribes, so it's a tough spot. But you're right. This past year and a half has made people feel like they're out of control. And there was a study that came out in July 2020 that showed that stress-induced cardiomyopathy had increased significantly because there's this very large connection with the health of our emotional state and the health of our heart. So why we say things like "I love you with all my heart" or "We gave it all our heart." There's this emotional connection there, and it showed that that organ is suffering during this time, this last year and a half.
Well, I'm glad you brought it back to the heart, so we can get back on track here. Not that was off track. This is all going to come around. This is all purposeful. All this stuff, we're talking about for a reason, and the stress, and there's different things that go into heart disease or heart attacks or any these cardiovascular problems, and a lot of it seems to be stress and just related to what we're talking about. But let's talk more about the heart, like physically, and how it works. First of all, that it does prefer to use ketones, or it is like this fat adapted thing really is what it prefers, and just how the heart physically doesn't work like we think.
Yeah, definitely. Yeah, so the heart definitely has this preference for ketones, and I think most organs do, but there's more research on the heart that I've seen than anything else. And so even in the presence of glucose, when they put ketones in there, like the heart tissue selects the ketones and uses them more. And so there's this one study where it showed that when they put a bunch of glucose in there and then they put the ketones in, that the glucose utilization went down like between 30 to 60%, which is a large amount. So the heart definitely prefers those. And I think the main reason is because you can get way more ATP from burning fatty acids and ketones than you can from glucose. And like I said, the heart is this very metabolically active organ. And so the more ATP it has around, the better. I mean, you think about it, it's really the only organ that, has this contracting muscle that's working all the time. I mean, yes, our liver is probably working all the time, and other organs are working all the time, but this is a very physically exertion, based organ. So I think that's really important. And I think that there's actually mechanisms in place that ensure that the heart has kind of first dibs on fatty acids, so that it can use those. One being that, fats are stored in the chylomicrons, and those chylomicrons are taken through the lymphatic system. And then they're dumped off pretty much more or less in the heart. But they have to go through the lungs first and then come back. And then the first tissue that it goes to is the heart tissue. So that's giving them first dibs. But there's also there's a mechanism that they recently discovered that shows that there's a direct communication between heart cells and fat cells through the nervous system. And so, the researchers were like, we could use this to, influence, like to change the heart and then influence weight loss. And I was like, oh, facepalm. It's more like the heart, like if it doesn't have enough fatty acids, it can signal directly to the fat cells saying, hey, mobilize fats. We need this to happen. Right. So yeah, that's really interesting. And then, the most interesting thing I think that I've discovered about the heart is that there's a large body of research that suggests that it is not the main mover of blood in the body. And it's not what we think it is, as like this pressure propulsion pump that's, sucking in blood from one side and forcefully pushing it out the other side. There's way more physics to it. And to understand this, you have to understand that the blood is largely moving on its own. And people will say, yeah, there's one-way valves in the veins, and that's great. That prevents it from backflowing, and like contraction of muscles, skeletal muscles will, create some flow. But it's even more than that, because there's some really interesting studies where they put tracers into the blood stream of dogs, and then after they euthanize the dogs, the blood continued to flow for up to 2 hours after the dog died. So it's like, how is this blood moving without the heart beating, without the dog moving, because it's dead? And it's also curious to think about how water gets from the roots of trees up to the leaves. There's no pump there, but it happens. And so what's happening is that there's this understanding of water that it can come into a fourth phase. And that fourth, we're taught there's solid, liquid, and gas. but there's actually this fourth state of water, and this comes from the lab of Gerald Pollack, and before that, Gilbert Ling, and there's guys have been looking at this for a long time. But basically, water has this unique ability to hold energy, and when it does, when it's energized enough and it gets next to a water-loving surface, it actually structures itself into something kind of between a solid and a liquid, kind of like a gel state. And this forms next to biological surfaces that are hydrophilic, like the lining of plant roots, but also the lining of arteries, and lymphatic tissue. And so when this happens, it creates an energy gradient based on how, which we can get into if you want to, the kind of the breakdown. But it creates this energy gradient that actually promotes blood flow or flow of water. And they've done this in experiments in the lab. They energize water and they put hydrophilic tubes in there, and the water just starts to flow.
First, how did they energize it? What does that mean?
So there's different ways you can energize it. So it's basically energy from the environment. So the original source of this was the sun. And in Pollack's lab, he notes in his book that infrared light was the most absorbed by water, specifically the 3,000 nanometer wavelength. But it doesn't have to be 3,000 nanometers. It can absorb all kinds of energy. But we also get energy from the earth, through like grounding and things. We can get energy from other humans. And so this is how you energize water in our bodies, but the water, like the natural water, like lakes and rivers and things like that, is energized by the sun and the earth. That's it. It holds energy that way. But you can also increase the energy of it by vortexing it. And that just means like spiraling it. Like I think of those, 2-liter bottles stuck together and you swirl them like that, like the vortex, those kids' science museums. But this happens all the time, like in rivers and streams. Vortexing in the presence of oxygen, it energizes the water more. And so when the water is sufficiently energized, and our blood is about half water, more or less, it forms this structured water next to the lining of the arteries, and that creates blood flow. So then, if the blood's already flowing, you have to ask yourself, well, why is the heart there? What's it doing? And it operates a little bit more like what's called a hydraulic ram, which is something that's flow activated. So usually a hydraulic ram is some device here, and it's got water flowing, down into it from like a reservoir or something. And then as it flows into there, it uses physics and stuff, and it pumps the water, more or less, quote unquote, pumps the water somewhere else, up to higher ground somewhere. And so the heart acts more like this. And that's hard to explain without the pictures and things. So people have to get the book for that. But I kind of lay out. Go ahead.
Yeah, no, you laid out, you have some diagrams in the book, but I also did look it up on YouTube to watch the videos, and there was some animations of how it works, and then I looked up some real hydraulic rams and how it works. And so yeah, it doesn't use any motors or anything. It just uses pressure. Basically, there's just these different pressures, and it goes into different chambers and pushes it up. And I saw this guy have a hose, and it was going way uphill from his river, and he was watering his property through this just with nothing but pressure. And also back to the ingredient you're talking about. I have this engineering background, but I also just remember growing up as a kid messing around with siphoning stuff out of a hose where you could suck on it. It's not the same as what you're talking about, but if you suck out of a hose, and then you could get water to flow because there's this like pressure gradient basically pushing it along. So you're talking about that this fourth phase water creates, well, it's a different type of gradient, but it's the same type of idea that can continue the flow.
Yeah, definitely. So it basically, when structured water forms, it actually cleaves the hydrogen off. So it's H2O, and then one of the hydrogens is cleaved off. And then that oxygen and hydrogen are used with other oxygens and hydrogens to make the fourth phase water. And since that oxygen is a bigger molecule than the other hydrogen, it's like the fourth phase water is a very electronegative space. And then the hydrogens that are left off, that are pumped off into the lumen of the artery, makes it a very positive space. And so you get this energy gradient that once it starts flowing in one direction, it doesn't stop flowing in that direction. And so like all those all those positive hydrogen ions are trying to get away from each other. Like charges repel. So
Mm-hmm.
as they're trying to get away, they just end up moving away from each other, and they just go off down the line, carrying whatever else is there with it. So yeah. So then, so why is the heart there then? If the blood is already moving, it's there because for two reasons. Because it is this contracting thing, and it does do a very small bit of pumping, like just enough to kind of get it through the chambers of the heart and not get congestion or whatever. But if you look at the orientation of the heart muscles, they're spiral in nature. And there's actually this amazing video on YouTube called The Helical Heart, where it's these cardiologists talking about how the heart muscle is actually one big band of muscle that's kind of wrapped around itself. And so when it contracts, it twists and spirals. And so that's what it's doing to the blood. It's vortexing it in the presence of oxygen, because there's always oxygen in the blood. Even if it's coming from the veins, there's still oxygen there. It's about half saturated with oxygen at that point. And so that is energizing the water in the blood, so that when it gets back into the arteries, it can form fourth phase water and keep the blood moving. So in a way, the heart is responsible for the movement of blood, just not in the way that we think.
Yeah.
So
And
that's
there was studies in mice. Was it mice
mhm.
to show this? Because before
Yeah.
it was only like in the lab, and people showed it in like a tube of water or something.
Oh yeah, just see the chick embryos. It was the chick
Oh yeah,
embryos.
chick.
Yeah. So
I was gonna say
yeah,
chick.
they
Yeah.
yeah they actually recently showed this. They stopped the heart of a chick embryo and looked at the microvessels under the microscope, and I have videos of them. That's really interesting. And yeah, it continues to move. And actually, at first, when they stopped the heart, the pressure in the system kind of changed a little bit, and the blood went the wrong way. But then after a few seconds, it started continuing going the right way again, and it just continued to flow as long as they applied, an energy source from the outside to it. It continued to flow, and they showed that the fourth phase water was forming there on the lining, which is pretty fascinating. So that's one reason the heart is there. The other reason is that it maintains pressure between the two systems, because there's an arterial and a venous system. And if we were to go for a run or do any type of exercise, then all the blood would want to go to the arterial side and be delivered to the tissues, because the tissue demand is what drives blood flow. And the heart increases its heart rate trying to keep up, because the blood is flowing faster. So it just has to keep up. But there's even studies that show that when you get to a certain point, the heart chambers almost they don't contract as much. They just allow the blood to go, because it's going so fast. There's really interesting studies in like endurance athletes and stuff that I talk about in the book. But yeah, if we started working out, all the blood would flow to the arterial side, and the venous side would collapse. But the heart is actually there to stop that from happening. It's kind of like this stopping up organ. It prevents it maintains the pressure between the two systems during intense movement and things. And there's actually interesting studies done way back in the day where they were trying to design a system like they thought the heart was, like a pressure propulsion pump. And no matter what they did, they couldn't get the venous side to stay under pressure. It's because the blood was moving on its own. They didn't have a system that was doing that for them. But yeah, pretty fascinating. It's there for different reasons than we think.
I love that. Yeah, that was the most surprising part, where basically the study you're talking about just kind of proved in a sense that the heart was not strong enough to just be able to pump through all the blood through our whole body. There's something else that must be going on. And that also the part with the exercise is really cool, because it's almost like slowing it down. It's like it's beating so hard because it's doing the opposite of what we think. It's basically slowing down the blood, or making it less. Well, it's got to regulate the pressure, basically.
Yeah, like there's studies, really interesting studies in soccer players, which are pretty endurance athletes, and there's like this, there's the phenomenon that endurance athletes have like a larger heart, and their heart muscle is bigger, and they assume it's because it's working all the time. It has to be larger to keep up with that, but it's actually larger to absorb more impact from more forceful blood coming in all the time, because they're working out all the time, so that it's a stronger wall pretty much to stop it, so that it can redirect it and put it back out to where it needs to go. It's really interesting, and there's a whole book on it by a guy named Branko first. He's a anesthesiologist, interestingly, but he wrote like a whole book, and it reads like a 200-page research paper if you're into that kind of thing. But it's really, really interesting.
It sounds like it's more like a dam more than a pump. And then I like that too with insulin. I like people talking about, I don't know if it was Ted Naiman and Ben Bickman, I just had them on, but just that insulin is more holding back the fat in the fat cells, not that it's like necessarily like pumping it in, like a lot of people think. It's more like holding it back like a dam. So it's just
definitely
interesting. Well, okay, let's keep going then. So should we get into cholesterol first? I mean, eventually we got to get into why atherosclerosis even happens. So maybe we could get into that LDL stuff. I've had other people talking about LDL, but let's just go into that.
Yeah, well, one thing I think I can add to this, and it's great. It's a great segue because, the fourth phase water that forms in the lining of the arteries, it's also called exclusion zone water, and it's called that for a reason, because the way that it forms, and again, the images are key here, but the way that it forms, it actually creates such little space that nothing can really penetrate it. And so they see this in the lab when it forms. They put like smaller and smaller things into the lumen of where it's forming, and they just go to the middle. They can't get into the fourth phase water. And so there's only very small hydrated ions that can penetrate it, like hydrated potassium and things like that, and the precursor to nitric oxide, which makes sense because that comes from the endothelia, and it can penetrate through there. But then, so in Dr. Pollack's book, when he's talking about it forming, he mentioned that the protein albumin couldn't penetrate it. And at first I thought that was weird because it was like a sentence by itself. And he was like, the protein albumin couldn't get through. And I was like, well, that's interesting. But then I realized that albumin is like one of the smallest things in our blood. So he was just making a point that, this one of the smallest things in our blood can't get through it. And so if you look at the size of albumin compared to the size of, say, LDL, LDL is way bigger. And so there's no way that if we have intact fourth phase water, structured water on the lining of our arteries, that an LDL molecule could touch the lining of the artery. And so that definitely puts a little spin on this concept of atherosclerosis, because it's, some in the field would say that LDL is causative. And I would say that it only ever plays a role if there's oxidative stress, inflammation, and things that damage the lining of the artery first. And in order to damage the lining of the artery, it has to damage the fourth phase water first. And so then we get into the conversation of things like oxidative stress, because remember that fourth phase water zone is very electronegative. So it has all these electrons it could donate if it starts to break down. And that's exactly what free radicals do. They go and they're looking to scavenge electrons. And so if we have high states of oxidative stress or high amounts of free radicals in our bloodstream, they could end up damaging the lining of the fourth phase water, and then therefore damaging the lining of the artery, which the body then has to respond to, and repair it in some way before it ruptures, which would be a catastrophic issue. And it repairs it by using things like cholesterol and minerals and things like that. But it's not those things that are causing or setting us up for atherosclerosis. It's the stuff that caused the damage beforehand. And the thing that solidifies this theory for me is that we see research that suggests that oxidized LDL or Lp(a) and things like that do associate more heavily with atherosclerosis. Well, guess what causes those things? The same things that damage the lining of the artery. So it's the presence of all these things that's creating this situation. It's not the LDL itself.
It's all making sense, because it's the simple way to think about it is it's the meat. It's not the meat. It's what else you're eating with the meat, right? People are just getting the wrong ideas in all aspects of mainstream science. Where, meat is fine on its own. But if you're going to eat a bunch of fries and highly oxidized oil and a bunch of other stuff around it, then you're going to have a problem. So it's like we're just blaming the wrong thing. So you should talk about how free radicals are even formed in the first place.
Yeah. So free radicals are just, it's kind of, I call it like the exhaust, just like your car runs on something and it makes a byproduct that's a waste product that's kind of toxic. That's the exhaust of a car. And so every time we burn, energy of any sort through those mitochondria in our cells, we make byproducts, and one of those byproducts is ATP, which is great. That's our energy currency. Another one is carbon dioxide, which we can usefully breathe out when we breathe. And then there's water as a byproduct, which is interesting because oftentimes we forget about that. We forget about that water is a byproduct of making energy. And so we talk about drinking water all the time, but if we have efficient energy, maybe we're making adequate amounts of water, or water that contributes to our hydration, at least the hydration of the cells. But then there's also a free radical, which is just a molecule with an unpaired electron, and these molecules really like to be paired. So I tell people, like my clients and stuff, that it's like the Looney Tunes Tasmanian devil, and it's just going around like crazy trying to find a paired electron or electron to pair with, and it will get it by any means necessary. So it'll steal it from another tissue. And so those are directly toxic to the mitochondria if they get to be in high amounts. But then they can start to toxify the cell and damage the cell, and then they can also tend to damage the system as a whole. But it's important to note that they're not all evil. They play a role. They're signaling molecules that tell our body when to turn on and off certain aspects of metabolism, and they signal other things as well. So they're not all bad. It's just when they get to be in too high of an amount. And so one of the things that can contribute to that is a metabolism that has to burn through a lot of fuel sources and end up creating lots of free radicals, which to me is a glucose-based metabolism. There is research that shows that burning primarily glucose causes more free radicals to be made than like a ketone or fatty acid metabolism. And so that's one aspect of that. But then, so that's one aspect, I guess, of what creates oxidative stress and free radicals. But there are many other things environmentally we should pay attention to as well that can also contribute to oxidative stress. Things like BPA and various other toxins, heavy metals, stress, those types of things, that we should pay attention to as far as our environment goes. But yeah, that's the oxidative stress kind of balance conversation.
I love that. Yeah. So it's like, what kind of diet and lifestyle can we have to reduce oxidative stress and these free radicals? And it's the stuff we're always talking about. It's just living like a human, ancestral living, just, not having heavy metals in your diet, like tons of cosmetics and plastics and deodorant and what else? They're just everywhere.
Oh yeah. Yeah. And that's the important thing to realize, is that you need to learn about these things in your environment, but realize that you're not going to be able to get rid of them all, or decrease your exposure to all of them. And that's why I think things like applying, things to your body that create the fourth phase water, energizing the water in your body is really important, because guess what? Those free radicals aren't going to touch the lining of the arteries as much if there's this barrier there that's taken some of the hit from those free radicals and the oxidative stress. I think that, things like that are incredibly important.
Well, so yeah, how would you do that?
So I mean, spend time in the sun, spend time with the earth, and then drink water. I mean, you can't really drink structured water, but you can drink energized water. Drinking structured water would be like Jello kind of stuff, but drinking structured water, so like spring water, or there's like structuring water devices that you can get in your home, that kind of stuff. But then I use infrared sauna because for me, I'm a pretty fair skinned guy. And so if I go out in the sun, I'm going to burn pretty quick. And so infrared sauna is a way that I could sit under infrared light for an hour rather than burning out in the sun. Because, I think like 40% of the sun's rays are like infrared, which is a good amount, but you can get a higher dose in the sauna,
Yeah.
So I use that a lot. I mean, you got to be conscious of electromagnetic fields and things like that. But that's the other thing that solidifies this for me, since I'm on sauna, is that this blood flow mechanism and how the structured water creates the blood flow. The research on infrared sauna and things like heart failure and atherosclerosis and, blood flow and high blood pressure and things like that is just phenomenal. I really don't understand why they're not more utilized in the field of cardiology when there's that much research out there that shows the benefit. And it's all because of these mechanisms we talked about. We're energizing the water in the body, which is creating the structured water, which is creating blood flow, which is taking pressure off the heart. So it's not in heart failure. It's decreasing blood pressure. It's protecting the lining of the artery, so we get more nitric oxide production. It's just, there's so many benefits. It's huge.
It is. And do you think it's more the heat and the infrared, one to other, or both? Because
I think it's a bit of both, because there's definitely research like with Finnish saunas that are not infrared that show benefit as well. And so just this is maybe a whole nother conversation, but there is an aspect to heating up the fourth phase water and letting it reform that is also beneficial, because when you heat it up too much, it kind of dissolves a little bit. And this gets into like, the structure of cells and things like that. But yeah, there is benefit in that regard as well, just by applying heat and getting that like almost like a hormetic stress. That's a benefit as well, but also the effect it has on the structured water. And then I think, because there are times when I sit in the sauna and I turn it up really hot and I want to sweat. And there's other times where I just sit in there for a longer amount of time and put it on like 90 and just don't sweat, but just have the rays on me, the whole time. So I kind of use both.
Interesting. Yeah. Well, I don't have access to a sauna quite yet. I want my own kind of thing going, but I'm here in Austin. It's 97. I go in the sun. For one thing, I'll tell you about sun. You just got to build up a base tan basically. So I go out, I do about 20 minutes on each side and I read books such as yours. And I go and I just get baked out there. I get baked by the sun, and then I leave when before I get burned. And then you can ramp it up each day. And pretty soon you'll be able to get a good amount of sun and infrared and all these other great things without getting burned.
Yeah, that's what I have to do too. I have to, start with like 10 minutes each side and work my way up to 15 and then 20. And then I get a little bit of a tan, and then I can stay out a little longer. But then like maybe like 3 or 4 weeks after I stop doing that, it's gone.
Yeah. Well, consistency.
Yeah.
So then, okay, what are some other ways to kind of mitigate these free radicals? Like we talk like sauna, these hermetic stress, environmental stressors. There's people talk about antioxidants, which are fine. I'm not into tons and tons of plant-based diet type of ideas, but I do like to eat, herbs or some like fermented vegetables with my meat, especially if, I'm grilling meat and there's like AGEs, when you're burning it, heterocyclic amines, you're burning meat. Well, let's have some sort of antioxidants to go along with it. But if you could talk a little bit like glutathione, stuff like that, like how to mitigate some of the oxidative stress.
Yeah. So, I mean, I guess first line of defense is like look into your environment and mitigate the exposure to those things as best you can. But, don't freak out about the ones you can't control, just do what you can. And then, so I tend to think along the lines of what you just said, that, adding some antioxidants to your food is beneficial in that, not that it increases antioxidants in your body, but it kind of bounces out or cancels out some of the oxidative stress things that are created in cooking. And that's the benefit to them there. Because when I look at the research on like ingesting, supplements of antioxidants or foods high in antioxidants, it doesn't really seem to have much of an effect. But one thing dietary thing that does seem to have an effect is ingestion of like collagen or glycine, and the different array of amino acids, because the endogenous antioxidants that we make, like glutathione and superoxidase mutase, they have components of these amino acids that we need to make more of them. And there's plenty of studies that show that dietary glycine increases, antioxidant production, endogenous antioxidant production. And that's where we want them to be created, because those free radicals I talked about, just normal free radicals created in metabolism, we want antioxidants right there to take care of them. That's how it's supposed to happen, so that we don't get a buildup of them. And so when I think about how many people's diets are deficient in things like collagen or connective tissue proteins and things, and how they're probably not getting enough of those that different kind of array of amino acids, then I understand why oxidative stress and inflammation is such a common thing among people. But I think that's a huge one to do that. So yeah,
Drink your bone broth. Yeah. I got some in nose
exactly.
and tail for you. We got bones
Yeah,
too. You can make your own.
that's right.
Yeah. Okay. So maybe we could go into the other ideas of atherosclerosis, or well, there's many competing theories. I want to know how yours fits into the puzzle. And also, I heard a podcast a while back with Dr. Sabatin, who's on Ivor Cummins' show, and you mentioned Dr. Sabatin in your book. So maybe you
Mm-hmm.
could talk about that, because it's kind of that one of these opposite things we keep talking about. It's kind of the opposite we thought of, where the things may be starting from the opposite end.
Yeah, and it's like opposite in a sense, but it's kind of the same as far as like my theory. Like, because the
Mm-hmm.
initial thing that starts it all off is that initial insult to the lining of the artery. So it has to, attack the fourth phase water and then the endothelia. And when that happens, then what Sabatin says is that the inside of the artery, like where the veins of vasorium, like the arteries that supply the arteries, what they're doing is they're responding to that. And so they have to actually grow, because when the inside of the artery gets insulted, the
Mm-hmm.
endothelia kind of thicken, the more cells deep. And to supply those cells with blood, then the vasovasorium from the outside has to penetrate in and grow new arteries into that so it can supply it. And when that's happening, um, there's when we get like half formed arteries, like in the process, like in the construction of those arteries, they're fenestrated. So there's holes in them. And so that's when certain blood components could potentially leak out and then deposit themselves in the lining of this artery. And so then if that continues to happen, we can continue to get damage to the lining. We continue to have to get more and more arteries forming, going deeper in from the outside in. We get this fibrous thing with this cholesterol kind of component to it, and there's really interesting studies that I talk about in the book that support the theory, in that in the very beginnings of atherosclerosis, we actually see LDL and cholesterol deposit itself at the very outer layers of where it starts to develop, not the inner layer where they're saying it's coming from the blood, but the
Mm-hmm.
outer layer of the artery. So it's really fascinating, but it all starts with the same thing, that insult to the lining of the artery. And once it's insulted enough, the body responds in some way that is protective in a sense, but it compromises certain function, like of the arteries, and then eventually can lead to bad things down the road.
Well, again, and you said there's cholesterol there in the picture, and then you said LDL specifically on the outside. This is what most people that I've interviewed and know about talk about, is that it's not the problem. The cholesterol or the LDL or these different parts of cholesterol are there to help. They're doing a service. They're not part of the problem.
Yeah, like if we allowed that damage to just keep happening without that, quote unquote spackle, the artery would rupture. And that would be a much bigger issue than having atherosclerosis that you could live with for years and then potentially reverse or try and repair. It's kind of like the cancer situation. The body chooses to do something in the situation that it's given, and long term, it's not a great solution, but short term, it keeps the cells
Preserve.
alive. Yeah.
Exactly. Yeah. It's again the Alzheimer's stuff. It's we thought that these plaques, what are they called? Amyloid plaques, were
Mhm.
the problem. It's like, oh, put on this research and removing the plaques, and then we finally realized, oh no, those are just helping.
Yeah. That's their body's response to
Yes.
the bad situation that we put it in.
It's not. They're not causative. They're just part of our body's process trying to help itself survive. And
Hmm.
speaking of that, LDL too, we didn't really touch on this, but many others have, how important it is, and how, I mean, I have not gotten sick in 6 years since I started eating, animal-based diets and going lower carb and all this stuff. And I have had higher LDL, and there's many studies showing it's protective, especially in elderly people.
Yeah, definitely. And that's one of the benefits of LDL, is it seems to be able to, help with immunity, or as far as like neutralizing, say, bacteria and things like that. And they've shown that in certain studies. Some of them I talk about in the book. But that's just one of the benefits of LDL. I mean, well, LDL, but the cholesterol that comes with LDL too, because LDL is just this packaging kind of protein that carries the cholesterol around. But without the LDL, we don't get cholesterol. And so if we try and aggressively lower LDL, we're going to miss out on the benefits of having that cholesterol around, which is, making our sex hormones and making vitamin D and carrying fat soluble vitamins around, and, communication between our cells and all kinds of stuff, the health of the brain, health of the neurons, across the board. It's incredibly useful. And then what even clues us into it even more is that when we look at the research on statins and the way they interfere with the process of making cholesterol, they also interfere with the process of all those steps to making cholesterol. And so lots of those intermediate molecules that are made in that process to making cholesterol are used for other things. And they help us explain why we see like increased rates of diabetes and muscle pain and atherosclerosis with statins, because we're preventing the body from making those intermediates that it needs to use for certain things.
It's these unintended consequences. We always think we have these magical, techniques to intervene in nature, and then there's unintended consequences. And then there's other studies just showing that, maybe the statin users have a little bit less heart attacks or CVD, but they'll have more other ways of dying or other problems. So it's just one more bit of evidence that shows you can't really cheat nature. There's like no free lunches. It's like, you're not going to get a heart attack, but you're going to die of something else.
Exactly. Yeah. And those benefits, like I talk about the studies in the book, like there's one study, I think it was like 1 in 20 were the odds, so like 120 people, or no, like 1 in 120. So 120 people had to take statins for 5 years to prevent one heart attack. And then like there was another one that showed like 62, I think. So 62 people had to take it for 5 years to prevent one heart attack, which are not the greatest odds for me. There's other ways that we could prevent that.
Well, yeah, and it's always risk versus reward. So it's like that those odds aren't great, but then you could have all these other problems like higher risk of type 2 diabetes or muscle problem, all this stuff. So it's like, or we could change our diet and lifestyle, and we would probably have less chronic disease in general. It would just,
that's right.
So, no one wants to talk about, these kind of interventions that we're talking about here. So now that we're talking about, you're talking about all these tiny little, is it veins or arteries that come around the insult? This was really interesting to me. I think they're called collaterals, like the collateral blood vessels. I don't know if they're vessels. I'm using the wrong terminology, but they compensate. This was really cool to kind of show that it's not just all about blockages, that they had just as much blood flow through these collaterals.
This is probably the second most fascinating, besides that the heart's not the pump. This is probably the second most fascinating thing. So I'm glad you brought it up. So there's all this research that shows that like bypass surgeries and elective stent placements. So like stent placements in an acute situation obviously saves lives, but like in an elective stent procedure, like where they see, there's atherosclerosis, we're going to go put in a stent, or bypass procedures, they're not really that effective for preventing, future events and things. And so I thought that was very curious. And I found some research by this guy named Dr. Giorgio Berardi. And he did these really interesting studies where if you've ever been to like the Body World exhibits where they do a cast of like the arterial system of a fish or something like that. He did this with the heart, and he did like thousands and thousands of hearts throughout his career. And he found that anywhere that there was a 70% or more stenosis of an artery in the heart, that the body had built a vast network of collateral arteries around it. Like angiogenesis made new arteries that went around it, and it was enough to fully compensate the tissue in the heart with blood. And that was in 100% of the cases where he saw 70% or more occlusion. And so in a way, the body has already bypassed that occlusion to supply the tissues. So it makes sense that if we try and bypass it again, it's not really going to give us much benefit. It's not going to hurt anything, but it's not really going to give us much benefit. And so I've spoken to a few cardiologists about that, and some of them have told me that that it's impossible for the body to form those fast enough, and that atherosclerosis forms faster than they could form. And I found a couple studies that showed that um, they induced a clot in, I think it was dogs, maybe
I
a
think it
different
was
animal.
dogs. I think it's
Was it?
dogs. Yeah.
Yeah. And the collaterals formed enough to compensate the blockage within 7 days, and another one within 4 days, which is pretty darn fast. It's just fascinating to me that the body finds a way. It figures it out. It's not going to let that tissue go without blood. It's that important. So yeah, just really really interesting stuff.
Well, it was, and you mentioned all these studies that show that the bypass success rate was very low. It's almost the same as if you didn't do it, and all these large studies. So that's kind of explaining why it's just not that's not the problem. Like
Yeah.
the body can take care of itself in that regard. But okay, so what does this all mean though? So keep like kind of finish it off for us. What do we get wrong in our mainstream view of the heart and how it works and how the disease process works, and then what did you find?
Yeah. Big picture, we've misunderstood the heart and its true function, as well as the pathology of heart disease and why the body is doing those things. I think that it's the same kind of thinking. I think that it's a big push in ancestral movement for like barefoot, that kind of stuff, and there's a lot of companies out there. Me as a chiropractor, I work with them that would say that you need orthotics. That's what you need. And I would say that we weren't born with orthotics. So if
Hmm.
something's wrong with the foot, it's not because of a lack of orthotics. So we've misunderstood the function. We tend to think that we as a society tend to think that we know better than nature, so to
Hmm.
speak, or nature got it wrong. We're smart enough to figure it out, and that's the same kind of thing we've taken, or the same kind of approach we've taken with heart disease, is that nature got it wrong, or nature is doing something wrong, like forming this atherosclerosis, and it's really just responding to the environment that we put it in. And in many cases, it's doing things to protect itself, and we're seeing it as pathology, when in reality, the body's working exactly as it's supposed to. But long term, it's an issue. And so we have to change the environment rather than thinking we can go in and just correct it and have like an egotistical approach to it. We have to step back and, I guess, be humble in nature, realizing medicine should really be about learning when it's important to intervene, but more importantly, when it's important to step back and
Hmm.
just, let nature do its thing, or change the environment so that nature can provide health again. Does that make sense?
Absolutely. Yeah.
Yeah.
So what how does one do that? I know we talked about it along the way, but like what are the main kind of interventions
Mm.
that you would suggest?
Yeah. So my big three for heart disease and for all disease pretty much is stay metabolically healthy, which to me is, for most people, whole food diet. And sometimes other people have to do more strict than that. Like some people have to go all the way carnivore, some people have to do keto, but for most people, a whole foods diet is going to do that for you. Um, Secondly, is reduce oxidative stress and inflammation. And we talked about, looking into your environment, avoiding toxins, eating a diet that creates less oxidative stress, managing your stress, because that's a very big promoter of oxidative stress, and then creating balance in your autonomic nervous system. Those are the big three that I think drive specifically heart disease, but all disease. And so, balancing the autonomic nervous system is learning about your development and potentially your predispositions to an imbalanced stress response, but then also putting your body in an environment that gives it signals that it's safe. Figuring out in your life what are the most stressful things for you, like what makes you feel out of control, or in unpredictable situations, and do your best to mitigate those sources of stress, because those are the most damaging. So yeah, doing all those things and just working toward uh, those big three are key.
I love it. Well, yeah, it's this ancestral living, and it all ties into that stuff. Why we got into the stress stuff in the beginning, or why how we're even wired or evolved from reptiles is it's that important that well we're going to get into your afterword, which is this whole curveball at the end of your book.
Yeah.
But well, yeah, just with there's different ways to get heart attacks. If we just call it a heart attack, that maybe you could just explain. There's different ways, and there's also different causes.
Yeah. Yeah. I mean, there's cardiac arrest, which very famously happened recently with a famous soccer player. I don't know if you saw, like, the Euro Championships, one of the
Mhm.
Denmark players collapsed on the field in cardiac arrest. And that's actually, if you look at YouTube videos, there's lots of soccer players that's happened to, and that's more of like the signaling to the heart is so off and messed up. I think that the heart almost stops functioning. It's like seizes up, and it's not getting that normal rhythm to contract, But then there's heart attacks where there is an acute blockage of an artery, where either a clot forms pretty much, I want to say, spontaneously, um, or a part of a atherosclerosis breaks off, and that's the newly formed, like, soft plaque people talk about. And when that breaks off, the body tries to repair it, sends in clotting factors, and it clots and plugs the artery. But then there's also plenty of evidence that we can get tissue death. So that blockage causes decrease in blood flow, and then the tissue dies, and we get tissue death of some area of the heart. And and then there's evidence, though, that tissue death can happen without a blockage whatsoever.
Mm.
Um, so that has to do more with an imbalance in our autonomic nervous system, sending improper signals to the heart, which causes it to shift its metabolism. Just like if you went for a run and the metabolism in your leg would shift to more glycogen stores and things like that. And so when that happens in the heart, which it's not supposed to, then we get more burning of glucose than supposed to happen. We get lactic acid buildup. We get changes in pressure. We get interference with calcium physiology, and we get tissue death. So there's different ways we can get what we call a heart attack. Heart attack is just like a blanket term for when all these situations happen in the heart tissue. Yeah.
Well, so now the curveball. So what happened in January?
Yeah. So yeah, about a few weeks before I was planning on originally releasing this book, I was just a regular Tuesday morning for me. I actually started having chest pain and had a pretty substantial heart attack, to my surprise. And there was a lot of stress related things that I think led up to this. One of them, the most stressful thing, happening a day and a half prior to when this happened. So I think that had a lot to do with it. But yeah, I called 911 pretty quickly. I realized what was happening, and they took me in, and they did a catheterization, and they put a stent in there. And I I questioned whether or not they needed to, because they dissolved the clot, and the cardiologist told me that there was minimal to no atherosclerosis, just a giant clot that had formed in my left anterior descending artery, which is the big one, the widowmaker. And so he said that he dissolved the clot and then placed the stent. And yeah, then I was faced with, Western medicine and how they would approach the recovery to that, after I had the heart attack. And I had, after this, I was laying there in the cardiac ICU thinking to myself, like, how can I release a book on heart health when this happened to me? And after everything I've done to prevent it, and who's going to believe me now? And it was a pretty low point for me, I'd say. But then what happened in the hospital, and what I experienced in those 3 days that I was there, um, totally changed my mind. I realized how desperately the information in the book is needed, and I don't claim that everything I wrote is 100% right, but I can guarantee you that the approach that they were taking with me in the hospital was not right. And so I just thought about all the people that potentially may be in that situation or have been in that situation and needed the information in the book. So I decided to release it, but I added this afterward, where I detailed my experience with the heart attack and what happened in the hospital, and And I mean, we can go into what happened in the hospital if you want to, but
Well, yeah.
that's
Keep going with the hospital or why you think it happened. And we talked
yeah,
about your history being a type 1 diabetic and,
right.
not eating right for a while or stressful events around the last year or the last day and a half.
Mhm.
But yeah, I mean, what was this sort of spontaneous clotting, you think?
Yeah. So um, my best guess, I've talked to obviously the cardiologists in the hospital, which were less than helpful, unfortunately. But I've also talked to other cardiologists more like in the know of what you and I talk about and things like that. And my best guess at what happened was, it was 2020 was stressful for a lot of people, but it was stressful for me in that I was losing control of a lot of things that I'd worked hard to create. And my wife and I were living apart. She had a job opportunity in England, and so that was actually kind of fun in 2019. We were traveling back and forth to see each other. I went to Europe 3 times that year, and it was kind of cool. But then 2020 that shut down, and I didn't know when I was going to see her again. And then, I'd worked hard to create like a speaking career aspect of my career, and those were all canceled. So that was pretty disappointing to me. Everything from the election to social injustice, that kind of stuff. I got caught up in it for the first time in my life, and we spoke about how you don't even watch the news, and I should have continued not to watch the news, but I got caught up in that a little bit. But then yeah, we got some um, really hard to hear news about a close family member, which I'm not going to reveal the details. But a day and a half before I had the heart attack,
Mhm.
it was. It was hard to take, and it was really the inability to resolve the situation that was the problem with it, because um, this person we couldn't get to, we couldn't help. They were pretty much on their own in that situation, and um, so yeah, we were pretty stressed out about that. I mean, I spent the whole day between when I heard that news and when uh, when the heart attack happened, like figuring out how I could try and resolve that situation to no avail. And so woke up Tuesday morning after a terrible night's sleep and had the heart attack. But I do think that stress throughout that year definitely created an inflammatory state in myself. I Blood sugars had been harder to control, which to me is a signal that I'm inflamed. But also like years of being type 1 diabetic probably laid some groundwork there, especially uncontrolled for more than half of those years. And then yeah, I had the stress response, and there's an overwhelming amount of research that shows that um, chronic stress, elevated cortisol, imbalanced autonomic nervous system um, creates clotting or increased clotting factors in the blood. And so I do think that that's ultimately, what happened. Because again, when they went in there and they placed the stent, he was looking at all my arteries. I asked him, well, how the other arteries look? And he was like, they look fine. I had a CAC score done in June, 6 months prior to this, and it was 0, which I was pretty
That's
impressed with
yeah. If
considering
everyone,
my background.
yeah,
Um,
that kind of disproves a lot of the stuff with the modern. I mean, the mainstream idea of how heart disease
mhm,
works. And so, yeah,
yeah,
it's a coronary artery calcium score of 0 is the best it can be. So,
yeah, yeah. So I was obviously really confused as to why this happened, and the only thing I can associate with it is the stress. And so that imbalanced stress response could cause tissue death in the heart without a blockage. But I was on a very metabolic flexible diet. I like to think that I was preventing that kind of stuff, but apparently it wasn't enough to prevent the increased clotting, because that's exactly what he said. He said there was a giant clot there, and he dissolved the clot like with antithrombotic, solutions and things like that, and uh, and then he was like, yeah, there was just mild to no atherosclerosis there,
mhm.
and in the other arteries, and I was like, huh. Um, so, so yeah, it's kind of scary, but that's what I think happened. That's my best guess, and I'll probably never know exactly what happened. But that's
Mhm.
okay. We don't have to know. All I know is that I'm still here, and I'm still able to, I guess hopefully use this to educate people and to help them prevent this kind of stuff from happening to them. But yeah, so then in the hospital, it illustrates how broken our system is. Because the first thing that happened to me was that they tried to tell me how to manage type 1 diabetes. And at this point, I know how to
Mhm.
manage type 1 diabetes. They wouldn't let me administer my own insulin. They wouldn't give it to me when I normally gave it to myself. And I kept telling them when I did this and how, and they'd see my A1C, which was like 6.4. So for type 1, it's pretty darn good. So they know I can do this, and they just wouldn't let me. I mean, it's probably like a liability issue. You know, they couldn't let me administer my own drugs. But that was frustrating because when I tested my blood sugar, when I got out of the cath lab, it was 300, and they didn't do anything. They said they were going to wait till the next meal to correct it. And I was like, no, we need to correct it now.
What were those meals?
Yeah, that's the other thing too, is that I feel like I was pretty much fasting for 3 days in the hospital because the meals were so terrible. I mean, it was, you know, processed carbohydrates, processed meats, stuff like that. And then the kicker is that when I think it was the heart failure nurse came to talk to me, and she was outlining what I should eat as a post heart attack patient to prevent heart failure. And so, you know, it was all like the low salt talk and everything like that. But also, she basically told me to eat a processed food diet, and I list some of the foods, or all the foods that were processed foods in the book that were given to me on a list. And I just couldn't believe that, like, fig Newtons were on there, and sherbet and things like that, you know, were on there. Vegetable oils was one of them. You know, it was like cook with these, not with saturated fats. And I was like, man. And I just realized, you know, because I've done this research kind of from the outside, you know, all this time, and now I was in it, and I really realized how bad it was. And there was all kinds of issues with medications they tried to give me. I was prescribed at least 11 different medications, and at this point I was open to taking some because I just had a heart attack and I wanted to recover, and but at the end of the day, and this was my decision. Don't do this, you know, like talk to your doctors, people. But, you know, at the end of the day, I realized that probably one medication they prescribed for me was probably worth me taking. And even then, I'm going to stop taking it here in a few weeks. So yeah, it was really disappointing to see that. But the most disappointing thing was that when I questioned things, when I asked questions about their therapies or why they're doing this or that, A, there was reluctance to explain it to me, and B, there was frustration with me, so much so that they would shut down the conversation and walk out of the room. And all I wanted, like at that point, I was not, you know, tapping into this research that I've done about the heart. I was like, hey, I want as much information as possible. I can't believe this happened to me. I want to recover the best I can. I want your perspective. And so when I would question their recommendations, I would just get shut down of conversation, and I never got their full perspective, you know? And that's the saddest part to me, is that there's no open conversation. And so I decided to release the book because I just want to open this conversation. You know, even if some of what I say in the book ends up being not accurate, or only part of it's accurate or something like that, it's like, clearly we need a different conversation about health and about heart disease. And that's the goal.
Yeah. And I don't think there's any like harmful information in the book. I mean, the only part that could be inaccurate maybe are some of these theories on, I don't know, some of these newer ideas, but they're based on other people's research. So my big question, I guess, last question here, we don't have time to go into too much detail. Just what is your takeaways of this, having that heart attack? Like, would you change anything in the book, or did you change anything different, or you're doing everything the same? It's just that you realized that there was this stress in your life, and then was it. You know what I mean? Like, you're not going to be like, oh, now I'm going to go on a plant-based diet now, because
No,
you're like, what you do is very indicative of like what you believe in, right? And so if you're going to continue to do the things that you outlined, then that's telling.
yeah, and yeah, I sat there, you know, in the hospital thinking a lot about this, like going through everything I wrote in the book, and I had like a PDF copy on my phone, and I was just like going through it, and I was like, I don't disagree with anything I just wrote, you know? And so, yeah. And even now, like, the book's actually unavailable right now because I had to take it down. I got signed by a publisher. And so we're working to republish it. And so right now I have the opportunity to change or update or whatever I want to do. And I can't think of anything, you know, everything that I wrote in there has some research behind it. And And then based on my experience in the hospital, it just almost reconfirmed everything that I wrote in the book. Like, they don't understand, and they couldn't give me a good explanation as to why this happened to me. Whereas I felt like I could at least give some explanation, or at least a theory, where all they could tell me was your LDL probably caused it, you know? And I was like, well, my LDL wasn't even that high, because I came off the carnivore diet, and that's the only time it's ever been high. I came off that and it wasn't. And there's even studies that show that what your LDL is at the time of being admitted to a hospital for a heart attack is irrelevant.
Yeah.
People have heart attacks with all kinds of
They have
levels
low
of LDL.
LDL, medium LDL, high LDL. There's no,
But that's all they could give me. And so it just, again, it reconfirmed that, I hope that people see the book as, like, I hope that cardiovascular researchers read it, because maybe it helps them reframe what they're studying, or add a new element to the study they're doing, or something that gives us more information as to what's going on. But yeah, I just hope that it, again, opens the conversation, and I really haven't changed anything besides increasing, like, my stress relieving practices and using more sauna and doing things like that. Increasing the use of those things for myself.
Yeah. It sounds like that's the only thing you could do. Like, like, what would you change? It's like, well, not have a huge stressful event a day and a half ago, or, I mean, I don't know what else you could do. So
yeah,
good stuff, man. Thanks for sharing your story and the book. And anything else? Where do people find you?
So my website is resourceyourhealth.com. And I'm on social media at Dr. Stephen Hussey, Dr. Stephen Hussey. You can find me Instagram, Twitter, Facebook, that kind of thing. And yeah, thanks for having me on. It's a great conversation.
Yeah, good stuff, man. I guess I'll maybe see you at the next event at Bill Schindler's Food Lab.
That'd be awesome.
All right. Take care, man.
All right, you too. Bye.
All right. Thanks, everyone. Thanks for listening. Thanks for sharing with a friend. Please give this podcast a review on iTunes or the podcast app. Go to nosetotail.org for all the great meat, seasonings, body care products, and more. Go to sapien.org to join the Sapien tribe. Get the extended show notes with all the links and extra materials, all the extra content, private website, and the Sapien program. If you're ready to make some lifestyle changes, we got your back. Sapien.org. Thanks so much, everyone, and we'll see you next week.